These are the solutions to CCEA's M4 Mathematics 2024 paper. So the first question we have is, it says ABC is a right angle triangle, AC is 15, BC is 7.5, work out the length of AB. So this is your x, this is what you're trying to find, it's Pythagoras theorem. So you would say your hypotenuse is 15, so 15 squared is equal to the x squared plus the 7.5 squared. 15 squared then minus 7.5 squared is going to be x squared, which means then x is going to be the square root of all that. So x is the square root of whatever that was, 15 squared minus 7.5 squared. And when I did that, I got 12.99, and that's going to be centimetres, and that's the 2 dp's. Okay, question 2. Tricky enough wee question. Question 2 was a water tank has the dimensions as shown. The cross section is a trapezium. The volume is equal to 522 meters squared. So it's a prism question. Volume is equal to your cross sectional area times your length, and we have to find the length. So we know that the volume is 522, and then the area is a trapezium. Now the area of a trapezium formula is given to you, thankfully, and the area of a trapezium formula is this. Area is equal to a half a plus b times h. So let's just put that in. That's a half times my a, which is one of my parallel sides, so 6, plus my other parallel side, which is 12, and then times my perpendicular distance between them, which is 4, and that's times L. So let's just tidy it up. That's 522. Let's just do that in a calculator. 6 plus 12 gives you 18. So that's going to be a half times 18 times 4, and then times L. So let's do 0.5 times our 18 times our 4 is 36. So you've got 522 equals 36 times L. Bring that 36 across, 522 divided by 36n will be equal to your L, and I worked out L to be 14.5 centimetres. Okay, next question is a frequency distribution. You've got to find the heights in metres of a number of trees are recorded for a science experiment. Results shown in table below. Calculate an estimate for the mean. It's called an estimate because you've got to find the midpoint x, and then you can do your fx column as well. So just zoom in on this a wee bit, make this a wee bit easier to see. So continue your table on along. So you've got your midpoint, and then you've got your fx. And what we're going to need to find is sigma f. Sigma, remember, means the total of all your, total of whatever, but it's the total of your f values in this case. And we'll also need to find the total of your fx column. So sigma fx. Now I've already worked this out, so I'll go through these quickly just to speed us through this. To get the midpoint, how you get the midpoint here is you add 100 and 110, and then you divide by 2. So that's going to be 105. How you get the next midpoint is 110 plus 120, divide by 2 to get this. How you get the next midpoint is 120 plus 130, divide by 2, 130, 140, divide by 2, 140, 150, divide by 2, 150, 160, and divide by 2. So the midpoints, you'll see a bit of a pattern here for them. I would do that for every one, just in case one of these things has a different width. These ones all have the same width, but I would sort of work it out just in case. So sometimes they will have it that they're not all the same width, and then people think it's just going to be like going up in tens as ours are here. I would nearly just work them out as I've just said, but that's what they all worked out for me. My fx, how I'm getting my fx, you're doing your f times your x column, your f times your x column, f times your x. Hopefully I've worked these out correctly. I had 630, I had 1,400, 1,495, 1,500, then I had 2,025, I had 435, let me just check that one, 3 times 145, yes it is, and then The last one was a 1 times 155, so 155. Okay, total those two columns up, 50 for this one. And this one, don't be surprised if it's big, and it is big, 6240. So your mean, you've got your table, your mean x bar is sigma fx divided by sigma f. So in this case, 6240 divided by 50, which works out to be 124.8, and I think that was meters. Now the last part of this question says, in which class interval does the median lie? Okay, we've got 50 values. I would say first of all, the median, because it's continuous, the median is just 50, your n divided by 2. So 50 divided by 2, it's that value, so it's a 25th value. So you've got to figure out where the 25th value lies, which class. Okay, now the first 6 values lie in here. The next 13, so 6 plus 13, takes you up to the 19th. So the 19th value is going to be in here. And then the next 12 values lie in here. So that means my median is going to be in this class. So it's going to be in here. If you don't like that, what you could do is a CF column. A CF being the running total of the frequencies. So 6 plus 13 is 19, plus another 12. Plus another 12 gives you 31, plus 15 gives you 46, plus 3 gives you 49. Plus 3 gives you 49 if this thing would let me write, and plus 1 gives me 50. So again, you can see my up to here is my 19th value. Then this would be my 20th, 21st, 22nd, 23rd, 24th, 25th, 26th, 27th, 28th, 29th, 30th, and 31st value in here. So my 25th value is definitely going to be in here then. Okay, so what was that? 20 is less than or equal to h is less than 130. That's what we've got to write in. 120 is less than or equal to h is less than 130 is what we write in. Okay, question 4. Question 4, nice wee number problem. It says, Alan wants to invest £2,400 for 2 years. He sees the following offer for compound interest. So Bank A, and what Bank A does, it gives 3% interest for the first year and then 1% for each year after. So he's only going for 2 years. We can do this in one go by doing the following. To increase something by 3%, multiply by 1.03, and then decrease it by 1% and multiply by 1.01. And then we do that, and I have done this already. So that was 2496.72. For Bank B, it's a little bit different for Bank B. It says 4% for the first year, 0.5% for each year after that. So for Bank B, it's going to be 2,400. First year is 4%, so 1.04, and then 0.5% is 1.005. So let's just go through, and that works out to be, £2,508.48. Read the question carefully. Oh, it just says calculate for each the value of the investment after 2 years. So that's it. Done. You don't have to do anything else. But let's just go through what we're doing here. So to increase if something increases by 3%, it goes up to 103%. 103% as a decimal is 1.03. If something increases by 1%, it goes up to 101%, so 1.01. And increases by 4% goes up to 104%, so that's 1.04. And 0.5%, it goes up to 100.5%, so that as a decimal is 1.005. So that's what we've done. Okay, read those questions carefully. Quite often it says which investment is better and by how much. Okay, didn't in that one, you just had to actually work out the values. Okay, next question. Okay, write this as a product of primes and prime factors. You can actually do this straight away in your calculator using your fact button. I still like to do it out, to be honest, but you could use your fact button. You could just do 125. You could just do 125, press equals, And then there's a wee button, you can see it's on a shift button. You have to press shift and then fact, and that will factorize it. Okay, and you will see if you do that, you will get the right answer. It's not doing it for me. Shift and fact. Yep, it gets 2 times 3 squared times 7. But let's just show you how you do this out a long way as well, because it is such a nice thing to do. Divide by 2, you will get 63. Divide by 3, you will get 21. Divide by 3, you'll get 7. Divide by 7, you'll get 1. So 126 is equal to 2 times 3 squared times 7. Okay. Next question says, find the HCF of 126. We've already got that, and 90. So we'll just do our factorising of 90. Divide by 2 gives you 45. Divide by 3 gives you 15. Divide by 3 gives you 5. Divide by 5 gives you 1. So to do these, write them out the long way. 126 was 2 times 3 times 3 times 7. And 90 is 2 times 3 times 3 times 5. And what you do is you circle what's common. So I have a pair of 2s, pair of 3s, I have another pair of 3s. So just read along those circles and you will see my highest common factor. I've got a 2 circled, a 3 circled, another 3 circled. And if you do that, make sure you work that out. 2 times 3 is 6 times 3 is 18. So it's a very easy mark given away. A lot of people would write down the answer as 2 times 3 times 3. Make sure you actually work it out as a numerical value. Okay, question 6. Nice question. It says, a rectangular basketball court is X meters wide. The length of the court is 13 meters long than its width. The perimeter of the court is 86. Form and solve an equation to find the value of X. So let's do a diagram. You've got your basketball court. It's X wide, and the length is 13 centimeters more. So that's your diagram. It also tells you the perimeter of the court is 86. So 86 is the length around the outside. You've got 2 of those widths. You've also got 2 of those lengths. So you're going to have 86 is equal to 2x plus 2x plus 26. 86 is equal to 4x plus 26. Bring that 26 across. Yes, bring the 26 across. You'll have 86 minus 26 is equal to 4x. 60 is equal to 4x. Xn is equal to 60 divided by 4. My x works out to be 15. So it's 15 meters. Okay. Right, this is a midpoint line. There was a midpoint, just anyone who's thinking of doing A-level mathematics, there was a midpoint equation came up on the AS1 exam, and it was actually a lot easier than this one, unbelievably. So this one tells you the midpoint, and then it tells you the points, and you've got to find the values. So the equation for the midpoint, if you've got two points, if you had x1, y1, and you had x2, y2, then the midpoint is x1 plus x2, then divided by 2, and y1 plus y2, and divided by 2. So that's what we're going to use here. So our midpoint, we were told, was 2, 5. So it must be a plus 3a, all divided by 2. So it was my x1 and my x2. And then the other one then is going to be b plus 3, all divided by 2. So you can set up 2 equations here. 2, this x value must be equal to this thing. And then in green, this 5 must be equal to this. So you can set up 2 equations and go for that. So 2 then, 2 then should be equal to 2 should be equal to a plus 3a all over 2. So if you just work that out, a plus 3a would be 4a over 2 is just going to be 2 is equal to 2a. Wee bit of working out, a works out to be 1. Or 5 is equal to b plus 3 all divided by 2. multiply across by that 2, you'll get 5 times 2, which is 10, equals b plus 3. Then 10 minus 3 is equal to your b. Your b equals 7. So a equals 1 and b equals 7. Okay, question 8 says a stepladder with sides of 2.3 meters is opened so that the feet are 1.4 meters apart. Calculate the angle to which the stepladder has been opened. Okay, a couple of ways we could do this. I think I would just do this one by splitting this, dropping this down here, perpendicular. What that does two things. It splits the angle in half. So this angle we're trying to find is now theta over 2, and this length would be 0.7. Okay, so let's just look at this triangle, and we can just use a trig here. So that's 2.3. That's 2.3. That's now 0.7, and this angle is theta over 2. And this is my hypotenuse, and this is my opposite. So I can use sine then. So sine theta. Oops, not sine theta. It was sine theta over 2 equals my opposite, which is 0.7 over my hypotenuse, which is 2.3. And that means theta over 2, my angle, is equal to, so you do sine the minus 1 of 0.7 over 2.3, and that gives me 17.71893 ... Notice I've used a whole pile of decimal places, because that's still being used in my working out. Multiply across by 2, and then I can go to 3 sig figs, 35.4 degrees to 3 sig figs. Okay, question 9 says a cylindrical flask has a diameter of 12 centimeters and a height of 25. The flask is full of coffee. A coffee cup is a hemisphere of diameter 9. Each coffee cup is filled to 90% capacity. How many coffee cups can be poured in from the flask? Okay, I've just realised I didn't notice this. Each coffee cup is filled to 90% capacity the first time I read it. So I need to be careful of that. So a cylindrical flask, let's look at the flask first of all. So our flask, the volume, it's a cylinder, the volume is pi r squared h. Now my r is 6, the diameter is 12, that means r equals 6. So volume is equal to pi times 6 squared times 25. So that is going to be, that works out to be 900 pi, which is exact. That's a perfect answer, okay, for the flask. So 1 cup then, 1 cup, and this is a full cup then. My R is 4.5. The volume of a cup then, because it's a hemisphere, it's going to be a half times, and the whole sphere would be 4 over 3 pi r cubed. So in this case, it's going to be a half times 4 over 3 times pi times 4.5 cubed. Now, before anyone asks me, yes, you could just write that as, for a hemisphere, it is 2 over 3 times pi r cubed. But if you don't see that, just multiply by the half, you'll get the same thing. And when I worked that out, I got an exact value of 243 over 4 pi. Now that's 1 cup. So 90% of a cup then, let's just do that. So 0.9 times 243 over 4 is going to work out to be an exact answer as 2187 over 40. And then remember your pi then as well. So that's what you've got. Okay, so the whole flask is this. Then 90% of a cup is this. So that's what 1 cup is effectively. And we want to find how many cups we can fill. So or say our number of cups is equal to 900 pi divided by 2187 over 40 pi. So the pi's just disappear there, so it's just going to be 900 divided by whatever that was, 2187 over 40, and that gives me 16.46 whatever, i.e. your answer then is you can fill 16 cups. You couldn't get 17. You'd have to round down. In this case, it's going to be 16 cups. Okay, question 10. Cumulative frequency diagram illustrates the length of delays of trains at Northside Station. Find the median. So your total is 30. I've gone across at 15. So going across at 15 and down. Okay, and I did that as best as I could. When I did that on the proper page, I got 12.25 minutes. Find the interquartile range. So the interquartile range, you're going to have to go across at 7.5 and down. And then you're going to have to go across it, whatever that's going to be, 22.5 and down. Okay, you would do that properly using your ruler. So I got 15.5 minus 8.5, which gives me 7, bang on 7, sorry, it just gives me 7 for my answer there. So 7 minutes is my interquartile range. Now the box plot illustrates the length of delays at Southend Station. So one comparison. So let's work out from this then. So this line here represents a median, so that's easy to see our median. That's our Q2 for this one is equal to 20. Q1 we need to find. Q3 we need to find. So Q1 would be this. So that would be what? 20. It's tricky to see there. I think I'd work that out to be 13. It's quite tricky to see. Why is this not zooming in? Yeah, I worked that out to be 13. That's maybe not quite right. That would be 12, 14, 16, 18. So 12, yes, it is going to be 13. Yep, it is going to be 13. And then my Q3, so again, that's going to be 20, 22, that's going to be 24, 26, 28. So it's going to be bang on 24. Okay, and that means my interquartile range is going to be 24 minus 13, which is going to be 11. So if you compare that to what we had earlier on, the median for the first one was 12.25 and the interquartile range was 7. So the median, I would say, the first thing is the median time delay is, let's say, longer at Southend. And here we've got a smaller interquartile range at Northside. So what the interquartile range is, it's a measure of spread. So that means if you have a smaller measure of spread, then it's more consistent. So smaller interquartile range at Northside, showing trains are more consistent, or a better word maybe would be reliable. So we'll say that, reliable. Okay, lovely. Right, next one says the price for 900 litres of oil increased by 28%. The new price for 900 litres of oil is £736. £736. How much did 900 litres of oil cost before the increase? So whatever poor soul wrote this exam is obviously finding oil prices going up a bit of a pain, as we all are. So here we have got then the price of 900 litres of oil is, the new price is this. So that means 736 is equal to the new percentage. So that's 128%. Now there's quicker ways of doing this, but my way of doing this, which I think makes it nice and easy, is I always go down to 1% and then I go up. The original is going to be 100%. So I just divide by 128 and then I multiply by 100, and if I do that I will get 575. It makes it nice and easy to see, but you could just do 736 divided by 1.28 and it would give you the same thing, but that's a nice way of setting it out that it's dead easy to see. Okay, next question. It says the diagonal of a rectangle is 26, the width of a rectangle is x, and the length is 34 minus x, sorry. Show that you've got this equation. So let's do a diagram. No idea what's going on here. So you've got your rectangle has a diagonal of 26, the width is x, and then that's going to be 34 minus x, and then by Pythagoras, 26 squared is going to be equal to x squared plus 34 minus x squared, and then we've got to do this out. 26 squared is 676, and x squared. Take your time and do this out the long way. This is a big mistake that people make, is not doing this and then they miss a term. That's 676 is equal to x squared. And over here, 34 times 34 is 1156. Then you've got minus 34x minus another 34x, which is minus 68x, and then plus x squared. Then tidy up, bring it all to one side, put it equal to 0. You'll have 2x squared minus 68x plus 480. And then divide through by 2, you'll get x squared minus 34x plus 240, which you can see is what we were looking for. Happy days. Lovely question, because you know you've got the full marks. It says solve the equation to find the possible values of x. Now this one actually factorizes, but there's no way in the heat of an exam, a calculator exam, I would be bothering to try and factorize this. So I'm going to use my quadratic equation. So quadratic equation says, remember, it's given to you if ax squared plus bx plus c equals 0, then x is equal to minus b plus or minus b squared minus 4ac. Square root of all that, all divided by a. So let's just look at our equation. Our a was 1, our b was minus 34, our c was 240. So we can just jump in and say then x is equal to minus b, which is going to be 34 plus or minus my b squared, which is minus 34 squared, minus 4 times my a times my c, which is 240, all divided by 2. And if you do that, the two answers you get are x equals 10 or x equals 34. Now, it says to find possible values of x. I would nearly argue because x was a width, it definitely can't be 34 then. If you look at it then, you definitely cannot be 34. Oh, here I've got 24, have I? My mistake, apologies. That should have said x equals 24. X equals 24. So it could be either of those really for your value of x, but you could argue because it's width, the x needs to be the smaller one. So x needs to be 24. X needs to be the 10, I should say, but I think they would say that. But so it's really 10 or 24. But I would really say, so really x is equal to 10 as it is the width, and the width is going to be smaller than the length. Okay, next one says a rectangle has a length of 4x minus 5 and a width of 3x plus 4. What is a quadratic expression for the area? Area, remember, is just equal to length times breadth, height times width, whatever way you want to set. And that's going to be 4x minus 5 upon 3x plus 4. If we do that out, 4x times 3x is 12x squared. 4x times the 4 is going to be 16x. Minus 5 times the 3 is going to be minus 15x. And minus 20. Tidy it up, that's going to be 12x squared plus x minus 20. There we go. A whole page do that question there. Seems like a bit of a waste. Okay, next one. Yeah, this confused me a wee bit, this question, I have to say. It said the triangle below shows ABC is equal to your 90 degrees. That should be an equal sign there. Equals 90 degrees. AB is 50. BD is 22. And it says calculate the length of AC. So you've got to find this whole length here. Now we can use Pythagoras first of all to find this length AD. So we'll call that x and we can find AD. So by Pythagoras, 50 squared is going to be equal to x squared plus 22 squared. So that means 50 squared minus 22 squared is going to be x squared. And if you just did, if you do that out, I'm going to get x squared is equal to 2016, which means x is equal to the square root of 2016. So that was AD, by the way, we have just found. So that's AD is 2000, square root of 2016. Okay, now the rest of the question, what we've got to find then is this wee bit here. I'm going to call it y, this wee distance, and we're going to start labeling this triangle. So if I call this angle here theta, if this angle here is theta, then this angle in here would have to be 90 minus theta. Okay, now this angle in here is also a 90. Sorry, that means on my small triangle, that's on the smaller triangle there, the ADB triangle, we've got that. On the bigger triangle, if that's this whole angle in here is 90, so if that's 90 minus theta, this wee bit in here, I'll do this in red, is going to be theta. This angle is 90, and if this angle is theta here, if this is theta, this then has to be 90 minus theta. So you've got similar triangles because you've got here in this small triangle, you've got a 90 minus theta. Here you've got a 90 minus theta. You've got a 90, you've got a 90, you've got a theta, and you've got a theta. So three angles are the same. That means they're similar triangles. Okay, so for the next bit, that's what we're doing, similar triangles. If you have another way of doing this, folks, I would love to know. I thought that was quite a hard question. I'm wondering, have I missed something very obvious? Okay, but we're going from small to big. So small side, which was CD, CD's corresponding side. Now let's look at CD. C comes from the 90 and the 90 minus theta. So 90 and the 90 minus theta on the big one is this 22. So it's over 22. So that was with CD that we were trying to find. And then what other side do we know? On the small triangle, this on the small triangle is 22. And on the big triangle, that is, let's look at where that comes from. So on the small triangle, it's between the theta and the 90 degrees. So theta 90 degrees is our AD, which we knew is our x, which was square root of 2016. So that's pretty tricky. So we can do a wee bit of working out then. Your CD is equal to 22 times 22 over the square root of 2016. And I worked out CD to be 10.77953. And then my whole line, so I've just worked out that bit, that was my CD there, we've just worked out. We need to add on our x as well. So the whole thing we need to do our answer, our AC is going to be the square root of 2016, and then plus whatever I've just worked out to be, what was that, 10.77953, which works out to be 55.7, and that's going to be centimetres. I've gone to 1 dp there. Okay, question 15. Question 15, we've got a, what is this, capture-recapture type question. It says a sample of 16 squirrels was taken from a forest. Each squirrel was marked with a die and released back into the forest. A year later, a sample of 20 squirrels was taken from the same forest. 3 of the squirrels in the sample were found to be marked with die. Okay, so 3 out of 20 were died, basically. So 3/20ths were marked with die. So that means 16 is equal to, or approximately equal to really, is equal to 3/20ths of the population. Okay, so to find the whole population, what you're going to do is you're going to multiply your 16 by 20 and then divide by 3. Okay, so if we do that, you're going to get 16 times 20 and then divide by 3, and I got 106. So that was my whole population was equal to that, sorry, and that's going to be 106.67. Let's say it's approximately 107. All right, so that is one way of doing that one. Okay, there's lots of other ways of doing that one as well. Okay, state one fault when sampling method with the sampling method used and suggest how to improve it. Okay, a couple of things. First of all, it's a year has passed, so it's 16 squirrels are taken from a forest. These squirrels marked would die and released back in the forest a year later, so it's too long. So one thing, I'm not going to write these down, but one thing you could say is it's too long between sampling. So you should repeat it after a week. Okay, so there's squirrels. A week is plenty of time for them to mix in. They're also animals, so they're going to breed, or they're going to die, or they're going to move out of the area, or other ones are going to move into the area. So that's why it's far too long a time. The other thing, which I didn't think of, was they're marked with dye. So the dye could wash off. So maybe put a tag on them instead of dye. So something along those lines. So either it's too long, or you put a tag on them instead of dye, as the dye could wash off. So something along those lines. Right, next question, 16, says, formula for h is equal to u squared over 2a. Calculate the upper bound. Okay, upper bound of a fraction. So for a fraction, the upper bound, or I'll say the maximum even, would be a nicer way of saying it. For a fraction, maximum is you're going to make the top line as big as possible and the bottom line as small as possible. If it had been the other way around, and they wanted to find the minimum or the lower, it would be minimum on the top and maximum on the bottom. Okay, but maximum is what we're looking for. So we've got to make our top line as big as possible. So top line as big as possible. It is just going to be, it was correct to 4 sig figs. So it's going to be 21.345. Okay. The bottom line is going to be 2 times my A. It's going to be as small as possible, so it's going to need to correct the 1 dp, so 975. And we do that. Oh, sorry, that top line was being squared, was it? It was indeed. The bottom line is just fine, right? Bear with me a wee second. Let me just do it in the calculator. 21.345 squared, and my bottom line is just 2 times 9.75. And when I did that, I got 36 to 2 decimal places. Question 17 says, find the equation of the straight line that passes through the point -2, 6 and is perpendicular to the straight line. So it's perpendicular to the straight line, 3x plus 2y equals 7. First thing, let's rewrite this equation. We have 3x plus 2y is equal to 7. Let's write that as, let's try and get it in the form y equals mx plus c. So 2y equals minus 3x plus 7, which means y is equal to minus 3 over 2x plus 7 over 2, which is 3.5. So the reason I've done that is I can read off what the gradient is, and the gradient is minus 3 over 2. So if our line is perpendicular gradient then will be the negative reciprocal of that. So change the sign of it. So it becomes just 3 over 2. Flip it upside down, it becomes 2 over 3. So our line so far is y is equal to 2 over 3x plus c. Now we're going to sub in our point. So we're going to sub in minus 2, 6. So instead of writing y, write 6. Instead of writing x, write minus 2. And then we'll just work that out. So that means 6 is equal to, that's going to be minus 4 over 3 plus c. Bring that across then, 6 plus 4 over 3, that's the same as 7 1/3 is equal to c. So you could say y is equal to 2 over 3x plus 7 1/3. You may also want to multiply through by 3 to give you 3y 3y is equal to 2x plus 22. But I think either of those would be fine. Next question, nice easy question, says factorize. So just divide through by 2, or pull out a 2, I should say, first of all. You're going to be left with 25 a squared x squared minus 9y squared. Now that's the easy bit. The bit that people will not get will be that this is the difference of two squares. You must learn this. You've got x squared. If you've got x squared minus y squared, that's the same as x minus y upon x plus y. So our first thing, 25a squared x squared, it is the same as, that's just going to be 5ax, and then 5ax in this bracket, and then we'll do our minus in this one, and then plus, and then the next thing was 9y squared, square root it, you're just going to get 3y and a 3y, and that's it, factorized completely. Next question says, write as a single fraction and simplify. Okay, this was a tricky enough question. So we want to take a common denominator really. So if you imagine this 2 as being 2 over 1, we want the common denominator to be 2x minus 1 upon x plus 2. So the 2, it's the worst. It needs to get multiplied by 2x minus 1, also by x plus 2. The 4 just needs to get multiplied by x plus 2. And the 3, oh, that was a minus. And the 3 needs to, minus 3 needs to get multiplied by 2x minus 1. So it's just a matter of multiplying out. I'm going to leave my bottom line for a minute, just multiply out my top line. This double bracket here after the 2, just make it one single bracket. So 2x times x is just going to give you 2x squared. Then you've got 2x times 2 is going to give you 4x. Then minus 1 times x is going to be minus x. So 4x minus x would give you 3x. And then minus 1 times the 2 is going to give you minus 2. And then over here you're going to have 4x plus 8. And then just be careful with this. You've got minus 3 times 2x is minus 6x. And minus 3 times minus 1 would be plus 3. Okay, our bottom line is still the same. 2x minus 1, x plus 2. And then we can multiply that out. You're going to have 4x squared plus 6x minus 4 and plus 4x plus 8 minus 6x plus 3, still divided by 2x minus 1 upon x plus 2. And if we tidy that up, I think that's all we can do really, tidy it up. You've got 4x squared, and then that's just going to be plus 4x. And then that's collecting all the x terms. You had 6x plus 4x minus 6x. And then you had minus 4 plus 8 is 4. And then plus 3 is 7. Now, I would just check to see if that top line factorizes. You're checking to see if it factorizes. So say, now this doesn't happen, unfortunately it doesn't factorize, but say it had factorized to be, I don't know, 4x plus 3 upon x plus 2, and then it was all being divided by 2x minus 1 upon x plus 2, then those would cancel out. But unfortunately in this case that doesn't happen. So we're just going to check how we're going to do that. We're just going to look at this thing. I'm going to look at the sum. Sum was 4, product is 28, and you go through your 28, 1 times 28, 2 times 14, 4 times 7, and then you're on to 7 times 4, and there's going to be no way that you're going to get, and them adding the two numbers, adding together to give you 4. So basically it doesn't factorize, so that's how you know that's as far as you can go. You could multiply at the bottom line, but I think that'll give you the full marks for this. Okay, question 19. Circle theorems questions, they were very nice. The way they've asked these, I thought it was a smart way to ask them, they were very good. It says, O is the centre of a circle, A, B, C, D are points on the circumference of the circle. Angle BOD at the centre there you can see is 115 degrees. On the diagram, mark clearly an angle that is 57. So 57 is half of 114. So from your circle theorem that says the angle at the centre is twice the angle at the circumference, then we know that one must be 57 up there. Next one says O is the centre of a circle, E, F and G are points on the circumference of the circle. H, F, J is a tangent to the circle at the point F. The angle HFE is equal to 49. On the diagram, mark clearly another angle that is 49. Now this is the alternate segment theorem, and you really should learn for the alternate segment theorem. It's a very difficult theorem to learn. You learn it as a diagram. So if that's A, then this angle would also be A, and the only other way you want to learn it would be, if that was my angle A, then this would be my angle A. And what you should do in a diagram is learn them with those two lines there. Should be horizontal really, but not that it matters. But learn it that way, and then just rotate your exam paper around so you get that sort of shape. So it's a pretty straightforward one here anyway. But that is going to be 49. So it's like this top one here. That's the way that we should have learned your alternate segment theorem. Okay, slightly trickier one here. It says L, M and N are 3 points on the circumference of a circle. LP and NP are tangents to the circle. Work out the value of X. Now this one, I looked at this and thought, okay, this is going to be 90 degrees, this is going to be 90 degrees, but that is not the case at all, because they are not, LM is not a radius. So what I'm going to do is create a radius by marking in the centre of my circle. If that's O, then that's going to be 90 degrees, and that's going to be 90 degrees, because there's a circle theorem that says the angle between a tangent and a radius is 90 degrees. And then back to the first thing the first part of this question, part A, the angle at the centre is twice the angle at the circumference. So 2 times x is 2x, 2 times 18 is 36. Now we have got a quadrilateral. We can forget all about our circles. We've got 4 angles, a quadrilateral, so 4 angles. So we've got 360 would be equal to 90 plus 90 plus x plus 2x plus 36, which means 360 is equal to, that's going to be 180 plus 36 is going to be 216 plus 3x. Bring that across then, 360 minus 216 is equal to 3x. That's going to be 144 is equal to 3x. X is going to be 144 divided by 3, which is going to be 48 degrees. So there you got 48 degrees for your X. Question 20 says, prove that a sphere of radius r and a cube of side r can never have the same surface area. Okay, right, no idea. So let's just get started. The surface area of a sphere is 4 pi r squared. For a cube, let's just draw a wee cube here. Side r, if you've got a cube, side r, one side is going to be r squared, and a cube has got 6 sides. So the cube is going to be 6r squared. That's what it's going to be. So prove that the surface area prove that a sphere of radius r and a cube of side r can never have the same surface area. Let's just try and put them equal. So let's put 6r squared equal 4 pi r squared. And what happens here is you could divide through by r squared, I should say. You could divide through by r squared, and then you get 6 equals 4 pi. But 6 does not equal 4 pi. So that's it. Okay, so it's like a proof by contradiction, right? Really. That's all we're doing. Right, next one is a histograms. The dreaded histograms questions, not normally a favourite of mine, I have to say. But this wasn't too bad as histograms go. So the histogram shows patients' waiting times in a hospital clinic during 1 week. So the hospital target is for 50% of patients to wait less than 20 minutes. Has the hospital met its target? Okay, so we need to find basically how many people have less than 20 minutes. So we're going to find the total here. So frequency is equal to the area of the bars. Okay, now you can do it that way, or you can say frequency is equal to the frequency density times the width, but the area of the bar is the easiest way to think about it. So let's just look at these. This first one is going to be 3 times 10. So that one is going to be 30. Bear with me a wee second, make this a bit bigger, but might actually be able to see it. So that's going to be 30 is going to be this one. This one's going to be 12 times 10. That's going to be 120. This one is going to be, that's going to be 5 times 18, is it? 5 times 18. So here, if we do that, 5 times 18, let's just check this. 5 times 18 is going to be 90. This one is, how wide is that one? 15 times 4. So 15 times 4. Yep, that's going to be 60 for that whole thing. And the last one is going to be, that's just 1 times 10. So that's going to be 10. So I've worked those out. I'm going to have to work out then that my total works out to be, when you add those all up, 30 plus 120 plus 90 plus 60 plus 10 works out to be 310. So the target hospital, the hospital target is 50% of patients to wait less than 20 minutes. So how many have waited less than 20 minutes? It was, yep, that should be all right then. So it's less than 20 minutes, sorry, is less than 20 minutes is equal to 150. So that is, let's see what percentage that is, 150 over 310. So that is 48%. Okay, so 48% of people, well, it's 48.38, but 48% of people wait less than 20 minutes. So we just say no. As only 48, I'll give it the 2 decimal places, 48.39% wait less than, what was it, 20 minutes. Okay. Next bit says 38 patients wait longer than t minutes. Work out an estimate value for t. Okay, I'm going to do this 2 ways. So I'm going to work out, we want 38 patients wait longer than t. So I'm going to go backwards here. So into this bracket, there was 10 in here. There's already 10 in here, so I need to go 28 back into this. All right, so it was 38, so I need to go 28 back into there. So that's where I'm going. So it's 28 out of 60, less than the 40. So the nicest way of doing it, 40, you can imagine 40 was 10 back. 40 was 10 back, and I need to go another 28 back out of that 60. So I've got 40, and then minus 28 out of 60, and that's times the width of that class, and the width of that class is from 25 to 40, so the width of that class is 15. Okay, now that's a different way than I would normally do it, but I just saw that one, I thought that's the easiest way of doing it, and it definitely is. If you don't like that, just keep watching and see another way of doing it. Bear with me a wee second, let me just check my answer I had here. I got 33 doing it this way. Now what we could also do, so it is t is equal to 33 minutes, or what we could do is we could go forward. So up until this point we had 30 values here, we had 30 values, then we had another 120, so this takes me up to 150, this takes me up to 240. There were, we need to get up to, what? We need to get up to 38 values, or 38 values way shy of being 310, so 310 minus 38 works out to be the 272nd value. That's what we need to find, basically. So we're up to 240. We need then, if you're at 240 up to this point, that was 240, you need to go in. This time you need to go in. We want to get up to 272, so we need to go in 32 values. Sorry, this thing is playing up. You need to go in 32 values. Okay, so it is my 240th value was bang on 25. So 25 plus 32 out of 60. And remember, the width for that class was 15. And if you do that again, let's just check. 25 plus 32 over 60, and that was multiplied by 15. And you get 33 minutes. Okay, now I definitely think the first method is easier there. So let's just run through the first method again. It was, you wanted the upper 38 patients. So this was from here to here. This was my last 10 values were in here. So I needed to go back another 28 values out of this 60. So it's 40 minus 28 over 60, and that was multiplied by 15. Okay, right, next question. Almost there. 2 more to go, I think it is. Okay, question 22 says, the diagram shows a square side, 3x minus 1 centimeters, and a trapezium with a base of length 5x minus 3 and a perpendicular height of 4. The area of the square is 1.5 times the area of the trapezium. By setting up and solving a quadratic equation, find the value of x to 2 decimal places, which would indicate to me I'm going to have to use my quadratic formula. Okay, that's a square. So that's 3x minus 1 as well, this thing here. So we can find the area of the square. I'll write this down first and then I'll zoom in it. So the square area is going to be 3x minus 1 upon 3x minus 1. I'll work this out in a wee minute. The trapezium, remember, is a half, let's just write down the formula, a half a plus b times h, which is a half times then going to be my a, which was 5x minus 3, plus my b, which was 3x minus 1, times my perpendicular distance, which is 4. Let's tie that one up, it's a mess. That's going to be a half times 8x minus 4 times 4. A half times 4 is just 2. So 2 times 8x minus 4 would be 16x minus 8. And then for my square, let's sort it out and then we can relate these. 3x times 3x is 9x squared. 3x times minus 1 is minus 3x. Minus another 3x is minus 6x. Minus 1 times minus 1 is plus 1. Now, write this down in words. It tells you the area of the square is 1.5 times the area of the trapezium. So that means square equals 1.5 times the trapezium. And then let's just put that in. That means 9x squared minus 6x plus 1 equals 1.5 times 16x minus 8. And then just go with that. So if we do that out, you're going to get 9x squared minus 6x plus 1 is equal to 16 times... Oh, where have I got that? Sorry. The trapezium. So 1.5 times the 16. So if we just do that, 1.5 times the 16 is going to be 24x. And 1.5 times the minus 8 is just going to be minus 12. Bring it all to one side, you'll have 9x squared minus 30x. And then that's going to be plus 13 equals 0. Okay, let's just write that down again. What do I have there? 9x squared minus 30x plus 13. Okay, so we've got that. Hopefully this works then. So your xn quadratic equation minus b, so plus 30 plus or minus my b, which is minus 30 squared minus 4 times my a, which is 9 times my c. Sorry, that was minus b plus or minus square root of b squared minus 4ac all over 2a. So I'll just put that into my calculator and then do that. Okay, my perfect answers I get are 5 minus 2 root 3 all over 3, or x is equal to 5 plus 2 root 3 all over 3, which means, let's work those out then. That press SD on that one and I get 0.51 to 2 decimal places, and the other one, let's go back and find the positive root. And if I press SD in it, I get x is equal to 2.82 to 2 decimal places. Okay, read the question. Find the value of x to 2 decimal places. Will one of these not work? Okay, I would imagine the first one won't work. So if you put this into this side here, so if I put 0.51 into it, so 0.51 times 5, and then take away 3, I'm getting a negative answer. So this one doesn't work. So my answer then is x is equal to 2.82. So just be aware of that. That's my value of x. I don't need the centimeters, but it's just 2.82. Okay, last question, and what a nice one to finish with. An algebraic fraction, my favourite. If you get one like this, I like to rewrite it. I'm going to write the fraction on the left just. Oops, I'm going to write my fraction on my left. So I've got my half, and then fire the other things across. So you have 5 over 5x minus 9, and plus 3 over 3x plus 1. And as well, what I would do, you don't have to do this, but I would just write it again, just because I really don't like having the fraction on the left hand side. I would write it like that before I do anything else. Now this is a common denominator one, so our common denominator is going to be 5x minus 9 upon 3x plus 1. That's equal to a half. Top line, that 5x minus 9 had to get multiplied by 3x minus 1, so its top line gets multiplied by 3x plus 1. That 3x plus 1 had to get multiplied by 5x minus 9. And then we go from there. Multiplied, you're going to get 15x plus 5 plus 15x minus 27. And that equals a half. I'm going to multiply across, and I've got my half times my then 5x minus 9 times the 3x plus 1. And let's tally up the left hand side. You're going to have 30x minus 22 is equal to a half upon, and if you multiply this out, 5x times 3x is 15x squared. 5x times 1 is 5x, minus then 27 would be minus 22x, and then minus 9. What I do is divide across by this half, so it divides across. Dividing by half is the same as multiplying by 2. So really that's just going to be 2 times 30x minus 22 is equal to 15x squared minus 22x minus 9. It's just a lot of tidying up this. So then 60x minus 44 is equal to 15x squared minus 22x minus 9. Bring it all to the left-hand side. You're going to have 15x squared minus 82x. And then you're going to have 44 minus 9, so you're going to have 35. And that looks good so far. You then use your quadratic equation. Your b is minus 82, so minus b is that. That's my b squared minus 4 times my a times my c, which is 35, square root of all that, all divided by 2a. And what that gave me was a nice answer, actually, of 7 over 15, or x is equal to 5, which showed me this actually would have factorized. So let's just look at how that could have factorized. So let's just look at that again. What was it? 0. It's equal to 15x squared minus 82x plus 35. You don't have to do this, but just in case you're really lovely old factorizing, that's going to be, my sum is minus 82, my product is 15 times 35, which works out to be 525. If you go through them, you'll find -7 and -75 work. So you could rewrite that as 0 is equal to 15x squared minus 7x minus 75x plus 35. Factorize the first two terms completely. And, well, the only thing comes out is x, so you're left with 15x minus 7. Then factorize the next terms. You could pull a 5 out, leaving you 15x minus 7 again. So 0 is equal to 15x minus 7 upon x minus 5, which means x is equal to 7 over 15 as we had, or x is equal to 15. And that's it. So you can see, but I would imagine the majority of people are, well, the majority of people are going to make a mistake somewhere there throughout that question. Hopefully you still get a quadratic that works. That means you only would maybe lose 1 or 2 marks maybe in that question, but I would just be using a quadratic formula. Okay, all right, folks, that is us done on that paper. Fair enough paper, to be honest. I thought not as bad as I have been in the past, but still you really do need to know your stuff.